Hello, my name is Isabela Lima, and today for my independent project, I will be presenting on storing and utilizing electrical energy. What is electrical energy, you might ask? Well, it is energy produced by electrons moving rapidly around. It is also energy transformed from electrical potential energy. There are two electrical attraction or repulsions between two charged particles, and the movement of positive charged particles through a wire or medium create a current, otherwise known as electricity. Well, we store and utilize electrical energy with capacitors on your left and batteries on your right. What are batteries? Well, they're an electronic device with one or more cells that convert chemical energy into electrical energy by creating a static electrical charge for power. It is a constant source of power that supplies electricity in the form of a DC, or direct current. Its basic unit of power is also known as a cell. Here on your right, you have symbols of the battery. This is the most common one that we know because of class. And here's an image of a battery. How do batteries work? Well, there are three main parts. You have the cathode, which is the positive end, the anode, the negative end, and the separator, where your electrolyte is located. Batteries have two electrode ends and a chemical inside called an electrolyte that occupies the space in between both electrodes. The electrodes that are connected to a circuit have electrons crossing from the negative to the positive terminal, or the low potential end to the high potential end, that produce an electrical charge, Q. Where can batteries found, you might ask? Well, just about any electronic device, in your home, in your schools, even in your back pocket. In this example, we have the flashlight. This is a complete circuit where you have your switch. Once you turn on your switch, the chemical energy inside of the batteries are converted into electrical energy in this closed circuit. Here you have your metal spring, your light bulb, where the energy passes through and illuminates this to allow the protective glass to reflect some of the light through. Applications of batteries can be in your electronics, household appliances, storage, medical devices, military, AI devices, auto vehicles, and emergency generator supplies that you might find in hospitals or even schools. Some advantages and disadvantages to using batteries is that their advantage is that they're able to store a lot, they have a high power density, they have a better leakage current than capacitors do, and they have a constant voltage. Some disadvantages is that they have a limited life cycle or lifespan supply in a small little battery or even a big one, and a long charging, this is supposed to be charging, time. Current and voltage is also limited inside of batteries, and they're also more temperature sensitive. What are capacitors? Well, capacitors can also be known as condensers. They have the capability to store potential energy in an electric field. They are passive, not active electronic components, and they have two terminal devices with two parallel plates separated by a dielectric insulator. So if my hands were two parallel plates and my arms were the wires, the energy would go through this positive side to the negative side and store energy that way. Here's an example of the symbols that you find for capacitors. This is the common one that we know because of class. And then how do capacitors work? Well, there are a minimum of two electrical conductors separated by a dielectric, or your insulator. When there is an electric field generated across this dielectric, it stops any current flow and electric charge begins to develop on these two parallel plates. Even though they're not connected to one another, they are electrically separated by a non-conducting substance like a ceramic, a porcelain, or even a Teflon. Dielectrics reveal what kind of capacitor it is and what it may be used for. Capacitors can range from small capacitor beads here at the left to high power capacitors in large-scale industrial operations here on the right. You can use capacitors in smoothing power supply outputs, frequency filters, high pass, low pass filters, coupling or decoupling signals, motor starters like in your cars, and then surge absorbers and oscillators. Some advantages and disadvantages to using capacitors. Well, the advantage to using capacitor in comparison to a battery is that there's a longer life cycle. There's a shorter charging time and a higher load current. It has better temperature performance in comparison to the battery that was temperature sensitive. And then some disadvantages is that it has a lower specific energy, a higher self-discharge. It's more expensive in comparison to the battery to use cost per watt. And then there's a linear discharge of voltage during operation. Both batteries and capacitors are capable of storing electrical charge, releasing electrical energy. They both have series resistance, and they both have the capability to create potential difference. Some differences between batteries and capacitors can be in the way that they store energy and the way that they are defined. Batteries have the capability to store electrical energy in the form of chemical energy. Capacitors store this electrical energy in a magnetic field. This can also be a reason why batteries store more charge and discharge slower because of the chemical reactions involved inside of the battery. Batteries utilize chemical reactions to store electrical energy in order to release their power slower. Capacitors release their energy extremely quickly because the energy is already there between both parallel plates. And then how are they applied? Batteries store a larger amount of electrical charge, while capacitors are used in high voltage applications and high frequency applications. Batteries discharge at a slower rate because of the chemical reactions. Again, capacitors have a faster discharge rate because their electrical energy is right there directly on the plates. Batteries have a reverse polarity in their electrical circuit, and then capacitors have the same polarity while in use. And then because a lot of that information was overwhelming, I decided to summarize everything in one table. And here we have the battery storing potential energy, releasing it in the form of chemical energy. And there is a better energy density. It's found in a DC component or direct component, has a slower charge rate in comparison to the capacitor. The charges are not separated, the positive and the negative, and it has a longer running or lifespan. And then capacitors, again, they use a potential field known as electrostatic to store the electrical energy. It has a lower energy density, an AC component, also known as an alternating circuit. It has a faster discharge rate because of storing energy directly on the parallel plates. The electrons are already pre-stocked, and it runs out almost immediately with that energy. An example of a battery is the iPhone. It contains a lithium-ion battery component that is extremely lightweight, high energy density, high capacity, and efficient, which is why we use it in our phones that have a long lifespan during the day. It's consisted of four main parts that we know in the simple battery: the cathode, anode, electrolyte, and separator. Every battery will have this. Without any of these components, or even just missing one of them, it will not function properly. And this iPhone battery has the ability to generate electricity through chemical reactions with the lithium ion found inside. Here is an example of the cathode, and here's an example of the anode, the separator between and the electrolyte fluid, in this case the lithium in between. The cathode regulates the capacity and voltage of the lithium-ion battery. Lithium is added into the battery and is put inside of the space, and this space for the lithium ion is called the cathode. The lithium is unstable by itself, so usually it's combined with oxygen in order to create lithium oxide, which is used as the cathode itself. It is also used as an active material to interrupt the electrode reaction inside of the battery. There's also a thin strip of aluminum foil that is utilized to support the frame of the cathode in its place. The frame is then coated with a compound composed of an active material like a conductive additive or even a binder. The active material lithium oxide is added in order to increase the battery's ability to conduct well. Then the binder acts as an adhesive to ensure that the active material and conductive additive fall into place together. The cathode's role in the battery is to indicate the characteristics that the battery will have. It also determines the capacity and voltage by the type of active material used. And the more lithium ion used, the higher the capacity will be. The larger the potential difference between the cathode positive end and the anode negative end, the bigger the voltage drop value will be. And then we have the anode. The anode propagates electrons through a wire. The anode is also coated with an active material, like the cathode. The anode uses an active material that allows for the electric current to flow through the outside circuit, while the lithium ions are released from the cathode. Lithium ions are stored in this anode when the battery is fully charged. How does the anode generate electricity? The conducting wire connects the cathode, which is the positive end, to the anode negative end. The reason I put negative to positive here is because this is the direction that the electrons are flowing between. The positive will get the negatives, the negative will get the positives. Lithium ions then flow back to the cathode through the electrolyte. The separated electrons from the lithium ions propagate along the wire, which generate the electricity. And then we have the electrolyte, where the lithium ions are propagated through the electrolyte. Electrons are propagated through the wire, and it is vital in allowing the use of electricity in a battery. Electrolyte is the medium that allows the flow of lithium ions in between the anode and the cathode. It's found in the middle of the battery. It has a high ionic conductive material, high ionic conductive materials are usually used for this, and so the lithium ions can move forwards and backwards with ease. Electrolytes must be composed of salts, solvents, and additives. The salts provide the path for the lithium ions to move through. The solvents are the organic liquids utilized to break down these salts. Additives are included in small amounts for different purposes. Electrolytes, again, grant lithium ions the ability to move to the electrodes, but it doesn't allow electrons to cross through. The speed of these lithium ions also relies on the type of electrolyte used. The separator establishes the safety of the battery. It is a physical barrier between the cathode and the anode, as shown here. It stops the direct flow of electrons, and it has selective permeability for the specific ions. In order for a separator to have its abilities, it must satisfy every physical and electrical chemical condition. And then here's a fun fact. Here's some of the history of the battery, starting from 1746 with Benjamin Franklin first coined the term battery, all the way up to 2010, where silicone nanowire was successfully tested with a 200 charge cycle. The battery has a large history. Imagine that. And then here we have Ohm's law and Power's law. Both are very important theories in the electrical energy, where with Ohm's law, current is directly proportional to potential difference and inversely proportional to resistance. And then current is directly proportional to power and inversely proportional to voltage or potential difference. And then here is Georges Simon Ohm, or I probably said his name wrong, but this is the guy who developed the theory for Ohm's law. And then here's an example of the delivered electrical energy calculations that I have. Example 1, you can go through that. And example 2. Example 3. Pause the video and make sure you got the solution. And then we have capacitors and a pacemaker. Well, capacitors are usually a small device implanted in the chest, and it's used to send electrical signals to begin or even stop, start, regulate a slow heartbeat. You obviously don't want to stop the heartbeat, but in general, if you have a high heart rate, you want to start it, and if you have a high heart rate, you want to slow it down. If you have a slow heart, you want to pick it back up. It is placed in the chest right below the collarbone, and is used to replicate and reinforce the heart's natural pacemaker, or the SA node, when it's not functioning properly. Parts of the pacemaker. There are 3 main components: the pulse generator, the leads, or the wires, and the electrodes. The pulse generator generates these electrical signals that make the heart beat. It is the primary part of the pacemaker system and can receive and respond to signals sent by the heart. The leads are simply flexible wires placed inside of the chest that propagate these electrical signals sent from the pulse generator to the heart and vice versa. One wire terminal is connected to the pulse generator, while the other is connected to an electrode, such as an anode, cathode. With biventricular pacemakers, leads are attached to both ventricles. Electrodes can be found on each lead or each wire, and the anode, which is negative, will attract positive, cathode is positive attract the negative. The pulse